Welcome back to Chapter 7 of the Linux Plus preparation course. Today we're going to talk a little bit more about the Linux kernel and their modules. This is one of my favorite chapters as we go through the course itself, mainly because it shows you how strong Linux really is. So in this course, or in this chapter, we're going to learn about the Linux kernel and what it exactly does. We're going to learn a few more commands and how we interface with the kernel itself. We'll explain how the Linux kernel module is modular and why it's so important. And we'll learn about some new tools to help us identify different modules. Okay. Now the big thing about this is the kernel itself is responsible for all hardware within our machine, plus so much more. And so we need to learn how important that kernel is, and if it does get corrupted, what would happen to our systems. So the kernel itself is the core of the operating system. It is what makes Linux Linux. It is the first program to load and has complete control over everything. Think of it like the engine of a car. It does all the heavy lifting while managing all the hardware and allowing all the other applications to run. Without it, nothing in the car would function. The kernel has a few key responsibilities. The first one would be memory management. Depending on how much memory you have in your system, this is what's going to keep track of all of the RAM. That random access memory is going to allow us to utilize other processes. So without it being efficiently managed, then the applications could step on each other. And so we don't want them to interfere with each other, and so it's going to do memory management. The other thing it's going to do is process management. It's going to act like the traffic cop for the CPU and schedule which programs and processes get to use the processor for how long. And now with current days, we have a lot of processors that are multi-core and multi-threaded. So we don't just have one processor lane to work with. Think about how many lanes on our highways we're starting to get. Some of these processors have 30, 40, maybe even 50 lanes that can be utilized per processor. And so process management is becoming a heavy lift for the operating system, and is one of those things where, as a traffic cop, it needs to understand what processes are where and when, so that way things get processed on time and in order. Other responsibilities that the kernels do, for one, is going to control all of our devices. So our device drivers act as the intermediary. In order for the operating system to understand how to talk to a keyboard or to a hard drive or into a webcam, we need to have drivers that can communicate with the devices. And these drivers must be built for the Linux kernel. So this is one of the main purposes of the Linux kernel, is for us to be able to plug in different input and output devices into our computer and utilize them accordingly. Now, all of this would be a moot point if we didn't have security. So we need a secure way for all the applications to start requesting for services, like opening a file or accessing a location on a hard drive. What we need is, well, we need that security cop again. We learned all about permissions in the Linux operating system, and so what actually enforces it? It's going to be the kernel of the operating system. While all things are being stored in our library, like with our file system, we still need to make sure that they're accessed properly and securely, and the kernel is what's going to enforce that for us. So there's a couple different separation in spaces on the computer itself. We do have what's called the kernel space. The kernel space is a protected area in memory where the kernel lives. It has direct access to hardware, and this is normally not accessible directly by users. We want to protect this space at all costs, because if something gets into our kernel space, now we don't have control over it, and now they're the middleman in everything that we do. Now, us as users, we normally run in the user space. This is where our shell is, our browsers, our command line, all of our processes. We don't have direct access to any of the hardware. We, in our user space, have to ask the kernel space for access to hardware. For example, if I wanted to open up Nano to edit a file, I would then ask the kernel space to access the file on the hard drive and give me space in memory to access Nano within the RAM. Now we can explore the kernel by using different commands throughout our terminal. And for instance, we can use the first command, which is uname, and this is going to give us a lot of information about the kernel itself. Not just about the name and version, but so much more information. Uname is one of those more powerful tools to help us understand, well, what kind of kernel are we working with and what is the current status of that kernel. Now, does the kernel have any logs? Well, yes, it does. Dmessage will let you see any of the kernel system logs. Okay. Now, this is one of those things that may need sudo access to run because guess what? We're dealing with a administrative task, so make sure that if you're using dmessage that you're using it with root credentials. Now we may want to browse the kernel space, and the kernel space is normally saved either in proc and sys. Those are the two locations that you'll find the kernel being living. So under proc, you'll notice this is where we're going to find the CPU and RAM and other devices that are controlled 100% by the kernel itself. Now, we normally can't manipulate too many things in these directories, but a lot of times we can read. We can see what's going on. So we can browse those virtual file systems by using sudo commands and using all the tools that we've learned before, whether or not we want to cat the file or use other types of commands. Remember, to be able to read any of those text files, we normally have our basic commands: head, tail, cat, less, and more. So here's how you use uname. Uname, Unix name, is basic information. So -r will give us just the kernel version. Uname -r is the version. Now, if we want to see all the information, we just do a uname -a. Now this is going to give us a whole bunch of information, including the host name and the kernel version and just a whole bunch of information, and print it all to the screen. Now, if you ever get asked, like in an interview process, how do I find the release version of your kernel, uname -r is probably the easiest and best way to do it, because you're not going to get all that other information along with it. But uname is definitely the correct answer. Now, if we want to look at those display messages, like let's say we were booting up and something happened during the boot up process. Maybe our graphics driver crashed or something happened, or for some reason I can't access my microphone or my webcam or something in that nature. We can use dmessage a lot to look at the log. Now, with that said, these are huge logs. So by typing dmessage and hit enter, you're going to have a sea of text. I don't know about you, but I won't be able to read that. So I might want to pipe that text into another command like less, so that way I can help navigate through that log, or I might grep for something. Maybe I'm looking for something specific to a USB device. Whatever I'm trying to do, remember, this is something that we can redirect that output into a standard input of another command by using that pipe command. Now, the kernel itself is not monolithic. How does this kernel support all the hardware in this world? Well, short answer, it couldn't. It can't. It would be very, very huge. So what we do is we create a modular kernel. And so the kernel lets us use modules. Now, what this means is, think of this like a car stereo. The car stereo may have a lot of inputs on the back of the car stereo. Now, if I don't need all the different devices, I may only plug in the devices I need. Now, with modules, all we need is a driver. We can add any device into our kernel, but we may need to give it the language pack, the instructions on how to use that device by giving it the driver. So here's back to our car stereo analogy. It has all these standard ports on the back. So if we want to play a CD, well, we'll need a CD player. If we want to be able to play it, we'll plug in the CD player in the back. then it will recognize and we can play CDs. When we unplug it, the receiver unloads that functionality and no longer can we play CDs. And so this is how the kernel works, is it's kind of like plug and play. It's only going to load the necessary drivers, the necessary code to operate and talk to that device whenever it gets plugged into the system. So let's say we plug in a brand new USB webcam. The kernel is going to detect new hardware. It's going to then identify that device. It will load the appropriate module into memory. And then when we unplug it, it will unload that module. So this will also save us on hardware. And this is the way that Linux kernels are very modular. You can do all of this automatically without rebooting the system. How do we manage those modules? Well, there's a few more commands that we get to learn about kernels. lsmod will tell us all the listing of the current modules that are inside of our system. Now, if you type lsmod and hit enter, you may find it could be quite long. It all depends on how many modules are connected to your computer. But you're going to find modules for all human interface devices, your hard drive, your RAM, your chipset, your sound drivers, your monitor. You're going to find modules for everything. Now, if we want information on the current module, like for instance, hey, did it load the correct driver? Well, I can do a mod info of a module that is currently loaded. For instance, if I'm looking for a graphics module, I'll look at my graphics card. Maybe I'll do a mod info of that module and then see, well, is it actually the correct module? If it's not the correct module, then it will let me know that, hey, I need to go install the correct driver on the system so that my device can operate properly. You could also do a module probe to help load and unload modules to your kernel. It's not just for that purpose to load and unload. It has a lot more capabilities, and I do highly recommend that you do a man of mod probe and see some of the other added capabilities of the module probing. So here's an example of doing the ls mod. For instance, this one's only taking the head, and we're only looking at the top 3. So the top 3 lines of running ls mod shows us 2 devices, the USB human interface device, and then we've also got an HID as well, which is linked by the human interface device. So we've got 2 modules in here, as in we have the USB human interface device, which is used by the human interface device. Now, some of these modules are kind of generic and they're hard to understand which one belongs to which. So we'll also see that which UUIDs are plugged into or what device they're plugged into. If we do a mod info, we can see exactly which file name is being used and which driver is being used to a certain module. So for instance, we wanted to know what module, which driver was being used by that USB HID, and we can see exactly which module is being loaded. If for some reason it's not the proper module, we can then take it to the next step and use the module probe. We can probe that module and see what's currently being used and its dependency. And if we wanted to, we can unload a certain module and load a different module in its place. So remember, most of these commands are going to need administrative access again, so these are sudo commands. So module probe, module name, we can either remove it or we can add it. It all depends on the different options within the mod probe command. All right, now the hard part. When hardware isn't working, we normally want to figure out what's going on. The first thing I like to do is I will look at the modules that are currently loaded. Did the driver even load for the module itself? Because sometimes it just doesn't load. It doesn't matter what operating system you use, if you plug in a USB device and it doesn't recognize it, because it tried to probe it and it tried to identify the proper driver, maybe it didn't really recognize it or identify the device properly. So is it even have a driver? It might not have a driver at all. If so, let's go check the log for the kernel itself. Let's look for that module under dmessage, or maybe we'll look for some errors under dmessage to see what happened. Now these logs are great. They normally will tell you what's going on. And if we need more information, we can even do a mod info to understand what the module does or where the module is fully located on our computer. All right, so we just talked about the kernel in short order, but remember how strong and how important the module is to our system. It helps us manage memory, processes, hardware, everything within our system. It's kind of like the gatekeeper between our hardware and our software. Without the kernel, well, our system would just be a glorified paperweight. Okay, this is what makes Linux Linux. Now we need to protect that kernel space, so we have it segregated in kernel space and user space. And remember of the different directories that we may have, such as sys or proc. We can use different tools now by using uname or dmessage as we go through to get the proc information. And the proc directory, remember, is that virtual read-only directory, but we can definitely get information from there. We learned that the kernel itself is modular and that all drivers need to be loaded within the kernel in order to support that hardware. And then we learned a few commands on how we actually look at that. We can do a listing of all our modules. We can get some mod info. We can probe our modules by loading or unloading. And we can see their dependencies along those drivers as well. So hopefully that makes a little bit of sense. Make sure you go through your labs, be able to play with these commands and see them in real life, because learning them here in a video versus doing them in real life is two totally different things. Now that you know they exist, go do the labs, go see what they do and see how they operate within your system. All right, I will see you for chapter 8. Have a good one.